Crop Watch Special Report starting now.
So in Nevada, every 5 pounds of flower has to be tested, every 15 pounds of trim, every 125 pounds of fresh frozen. All right, this is our intake room. These are our intake technicians as well as our intake manager. And these are the guys who first start with the manipulation of the cannabis. When it comes to the lab, the first thing we do is give it a barcode and enter it into our laboratory information management system so nothing gets lost, nothing gets swapped, and we keep track of everything. Then if you look over here, you see we have a photo box. Everything gets a photograph, and that's the photograph that ends up on the certificate of analysis. You can see next to that there's a microscope. Everything gets a visual inspection to make sure there's no foreign matter, there's no powdery mildew, or anything that shouldn't be there, right? Lots of stuff has just come in, and that's what these guys are starting to prep. The stuff in the brown bags are stuff that's being destroyed. So after all of that is done, we have to homogenize every sample. That means just grinding it up so it's all the same throughout the entire 10 grams that we acquire out in the field. We take one of these whack-it machines. We take a boat right here, right? The cannabis will be sitting in here. You take the whack-it machine, you press it down, and you can see that grinds it up with that little chain. And then we use one per sample, right? So we have lots of these. And as we use one, and after we're done, it goes to the side. Somebody else washes it and cleans it and sterilizes it, so then we can use it again later. But we have about 40 of them in the building to make sure that we can just do one per sample.
Great.
Right? Once it's all homogenized, it looks like this. And it's kind of like a sand-like substance. It's still a little sticky because it is cannabis, but you see how it's kind of powdery.
Right.
And this is what the analysts end up taking their samples from.
Gotcha.
Once all of that is done, behind you can see these samples are set for moisture analysis. These are moisture analysis balances. In Nevada, everything has to be below 15% moisture, or else the consumer is buying lots of water, right?
Wow.
So we take some of this powdered cannabis. I'll open this one up. We put it on there like that. There's a halide light in there, and we weigh it. We turn the light on. The light dries it out completely. Weigh it again, do some math, and figure out what the moisture content is. We were probably 75 to 100,000 samples in. We just hit our 10th year, right?
Congratulations.
And we've had maybe 5 failures for moisture.
Wow.
Nobody really fails. Once all of that happens, then it goes next door. And it sits on the counter. Here, from this counter, the analysts take their samples, whichever it is that they're performing today, and they do their own prep. So we have scales right here that are calibrated each and every day by us, and then twice a year by the company that comes out and does it. This also keeps us ISO certified, which we have to do every year as well. Each analyst does their own assay. So we test for pesticides, we test for heavy metals, we test for a complete microbial scan, we do cannabinoids, terpenes, and I think that's it, right? So we have our pesticide chemist, we have a cannabinoid chemist, and then a chemist for each of the other assays as well. They all prep their own samples, and that's what they're doing now. Faith's been with us for a long time, and she has moved here from Florida, and she's doing a great job. This is Denise. She is our lab manager, and she is also in charge of cannabinoids as well as all of the other things that happen inside the lab.
Very important person.
That's right, very important. And but from a consumer standpoint and from a producer standpoint, she's the cannabinoid queen. So she's very important. This is what we use to detect only one pesticide. So it's a $350,000 machine that the state makes us use because we can't see a pesticide on the other machine. So it's a like I said, it's a GCMS, which stands for gas chromatograph mass spectrometer, right? Which, again, finds one pesticide that we never find because nobody uses it. Right. This is an LC mass spec, which is liquid chromatography. And this also has a triple quad mass spectrometer in this. This is what we use to test all of the other pesticides In Nevada, there's 23 pesticides that are approved, not really approved, but that are on our list that we test for, right? Some of them have zero, levels of acceptability. So if we see a trace even, it's a fail, okay? When someone fails for pesticides, it's a destruction of the harvest, or of the 5-pound lot, or the 15-pound lot, or whatever their lot is that we're representing with that sample. Okay. We don't get lots of pesticide failures in Nevada. In the early days, we used to get a lot, but we don't anymore. It's very, very expensive to have to throw away 5 pounds a week. From this computer to the other computer, all the way on the other side, is all for heavy metals. And it's so big because we have 2 machines. This is an ICP-MS, and the P in ICP stands for plasma. Okay, we have argon gas, and with argon gas, we make a flame, and it's a plasma flame. And if you bring the camera close in here, you can see the flame that's in there now. That flame is the same temperature as the sun. And what happens is, we take that sample, okay, we put it in a long test tube, like you see right here, okay. We put some acid in the tube with it. It goes in this microwave oven where it spins around for about 18 minutes, and very high pressure, very high heat. It dissolves everything into an ugly liquid. Then we filter out the liquid into another vial, which you see over here. And you see it's much cleaner on this side, right? This is what gets shot through the machine. That liquid gets shot through that flame, and everything is destroyed except for the heavy metals.
Wow.
And that's how we check for heavy metals.
Oh my
Which is very intense. Nobody really understands it until you really explain it.
Yeah.
Right, and we test for cadmium, arsenic, lead, and mercury. And that's all for heavy metals. See right here is a GC mass spec, another gas chromatograph mass spectrometer, but we use headspace vials, so it's called a headspace. So we use this machine for residual solvents. So any extract that's made with anything other than CO2, we have to test for it. And it has to test below 500 parts per billion.
Repeat that one more time.
Yeah, it has to, no, part per million, sorry.
Okay.
Part per million. So it has to test for under 500 parts per million. So, which is usually the case. If something does fail, the producer has an opportunity to cook it again and get all the, butane or propane or whatever they're using off again. They do have to do another test, but it's a process and it's a way to save, the whole lot, 2.2 pounds or the kilo. So we use this for residual solvents, and it's also our backup machine for terpenes because they do the same thing. But mainly for terpenes, we use this one in here. You can kind of see it moving here. Once the analyst puts everything on, then the machine just goes to work and the robots take over and they just kind of do the magic for us. Then the analyst will come in and read the data and make sure that all the data is correct.
Gotcha.
But this is a GCFID, and this is what we use for terpenes, which, as I'm sure you know, is the taste and the smell, as well as many other physiological advantages to ingesting the right terpenes, and that's what we test in here. This machine also serves as a backup for our residual solvents. Same kind of machine, they're both GCs, they're both mass specs, but one uses the headspace vial and one uses a direct injection.
Gotcha.
That's what the difference is.
All right.
These gases are the carriers for the liquid that goes through all of the machines. So in order to push all of this stuff through, we use helium, nitrogen, and argon gas for the flame. And we have a nitrogen generator, so we always have it.
And where did you get these sticky pans? I like these.
Oh yeah,
These
they're great. These keep us from bringing bad stuff and dirt and grime and bacteria into the actual room.
It's like a human rat
Yeah.
trap.
That's right. That's exactly right. This right here are HPLCs, high pressure liquid chromatography that we use for cannabinoid analysis. We test for 11 different cannabinoids. Even though the state only makes mandatory 4 of them, we think it's important that patients and consumers know exactly what they're ingesting. It doesn't cost us that much more money in order to deliver that information.
Very important.
We think it's very important. Same thing with terpenes. The state only recommends 9, and we do 18. So it's important to know all this stuff. So redundancy with cannabinoids as well. We use one of them for concentrates and edibles, the other one for flower. They can be used both for each, but it's gone well for us in order to keep this one clean, and not mix the two. We do mix the two when we have to, if the machine goes down or maintenance involved or whatever. We also randomly will test the machines against each other to make sure they're getting the same results, see if anything has to be adjusted or fixed in any way. This is our microbiology room. This is the micro one. This is Mackenzie and Farah, our 2 microbiologist babes. I mean that respectfully. We do 2 different kinds of microanalysis here. We use both plating, where we use rapid plates, and we use plates for
E. coli, coliforms, Enterovacner, and yeast and white.
And then everything else we use qPCR. So we look at the DNA of the organisms in order to determine how much is there, if it exists, and so on, which I'll show you in the other room. But in this room, we do a lot of prep. We do the prep for the plating, and everything else is done in the next room.
Thank you.
Here is our PCR room, as well as our incubator room. So these are incubators where we put those rapid plates right there. As you see those are 3M plates. And basically they sit in there for 72 hours when we're testing for yeast and mold. And after 72 hours, we pull them out, do a count, and figure out how contaminated, if at all, any of the plants are. PCR, this is a Biorad qPCR machine, and we use this for Aspergillus analysis. The great thing about what we do here specifically is that we use what's called free DNA removal. That means that we remove all of the dead DNA from the sample. So when we test, and we're doing that presence of test for Aspergillus, meaning is it there or is it not there? Some labs will test and it's dead, so it's not really affecting the plant. So we remove all of that dead DNA to make sure that we're only testing for live DNA, and if we do find it, it is a fail. And if we don't find it, obviously it's a pass. Aspergillus and yeast and mold are the 2 biggest hazards in cannabis failing tests. So we take this serious, and that's why we do this extra step, so it's advantage client. Right. So we have several different machines. We have the Biorad, we also have BioMeriU, and we use this for Aspergillus, Steck, and Salmonella. Very clean. It's cleaned every day. Everything is cleaned with alcohol and bleach. All right, so there's always a little bit of weed or edible or substance left over. You remember the 50 ml vial that we showed you that we first homogenized in? Well, it goes down and down and down until there's just a little bit left. There's always something left because we only use a 0.5 gram to 1 gram for each one of those assays, okay? So there's always some left over, and we have to destroy it. We have to hang on to it for 35 days because that's what the state requirements are. And on day 36 is when we destroy it. You saw in the front room where all those brown bags were, right? So those brown bags are gonna end up in here, but what we have to do is take them out of the brown bags, out of the 50 ml tubes, and then pour them into these 55-gallon drums. We do a layer of cannabis and then a layer of cat litter. And that's the way the state says we have to destroy it.
Cat litter.
Cat litter. Wow. So we would love
some cat litter.
Yeah. We would love a program where we could take this leftover stuff and maybe donate it to veterans or patients who can't afford stuff.
We could talk about that.
Yeah, we really want to do that, but it's a lot of red tape in Nevada in order to make that happen.
Gotcha.
We tried it in the first regime. We tried it again in the second regime, so which was the Department of Health, then it was the Department of Taxation, and now it's the CCB, which is the Cannabis Control Board. Yep. So they have their own entity. So we are going to do a presentation to them later on in the year to try to do that because it's such a waste that we throw all of this stuff away. And basically, when it gets filled up, the layer of weed, the layer of kitty litter. We also take the vials, and the vials go the same way. So a layer of vials and a layer of kitty litter, and then so on and so on. Gotcha. And then an environmental company will come and will take it away, and then they use it and they mix it with concrete. And so Vegas is being built on pot.
Wow. You hear that, guys? You can lick those buildings, baby.
That's right. These are just backup gas tanks, helium, hydrogen, and nitrogen. This is what we call our lab in a box. This is one of the boxes that our technicians take in the field. We wear complete hazmat suits, disposable hazmat suits that go from cover your feet all the way to your head. We also wear masks, gloves, and everything else necessary to make sure that we are clean walking into a facility. In between samples, we even change gloves and we clean the utensils with both alcohol and bleach to make sure that we don't contaminate anything. It's a real important phase of what we do, because when someone fails, which is the worst news they could ever hear, right, it's never going to be because it's our fault, right? So even when we sample in the field, we'll separate the 2 micro bags. We take 12 grams, right? So 2 grams, a gram here and a gram here, goes in separate bags, and they do the experiment in the bags. So it never even comes out of the bag, so we don't touch it ever, right? Not even at the facility, because we have gloves and a forceps, right? So we don't ever touch anything, right? And again, we do that. It's cost a little bit more money, takes a little bit more time, but it's advantage customer, because the worst call you could make is your stuff has failed. You cannot go sell it, right? That's terrible. And then our 35-day retention freezer. That's where everything stays. You saw those brown bags in the beginning. This is filled with lots and lots and lots of those brown bags, 35 days worth of stuff. And like you saw on day 36, they get destroyed and they end up in those 55-gallon drums. And of course, our prized possession, which is our paint shaker. This allows us to mix samples 50 at a time. So in the lab, you might have seen some smaller table shakers, doing like 6 or 7 samples. Here we can take 50, put them in this, set the timer, let it go. The analyst can go do whatever they need to do. Bell goes off and they come and get their samples and put them in the machine. Because when they mix whatever chemical they're mixing with the cannabis, in order to extract it, it has to be mixed. It has to be shaken. And if it's not well shaken, you get a not good sample, right? So this makes sure that every sample is exactly the same every single time, because it has to be. And that's the life cycle of a sample in a cannabis lab.
I want to thank Todd, the amazing staff here, and to actually see a life cycle of a sample the way we just do, it's going to be amazing. I've learned a lot. I'm going to have to watch it a couple of times because he says some amazing words I don't remember. Okay, I'll see some amazing people, but please make sure you connect with Digi Path Labs. If you're here in Las Vegas, if you're just visiting and you're in the cannabis industry, especially in California, in Southern California, I urge you to get with Todd and Digi Path. Just learn how your product is supposed to be handled, and you come back with those standards. Now, I guarantee you're going to have better results with a lab like this. I'm Eric Kennedy. I'm going to go and get some more knowledge from my man Todd, do a little in-depth interview real quick, but this is amazing. Make sure you check us out, EMTRI'S Network. Out of here.